Welcome back, students. Welcome to the session 12 from the playlist of wave optics. The topic is the Young's double slit experiment. This experiment was conducted by an English scientist by the name of Mr. Thomas Young. He conducted this experiment in order to study the interference pattern of the light waves. And in this experiment, he took two opaque screens, and in one of the screens, he made two pinholes as shown in this figure. So this is x dash is the screen in which he made two pinholes, and I have depicted those two pinholes as S1 and S2. And then he placed another screen, another opaque screen at a distance capital D from this screen, that is x dash. So these two screens are separated by a distance say capital D, and the distance between these two pinholes is taken as small d. Now here the distance between the two pinholes is very less in comparison to the distance between these two screens. So this is one of the assumptions which has been taken in this in this experiment. Now these two pinholes are illuminated by a single source of light, say S, and this single source of light is placed on the line joining this joining O. O is the center of the screen y dash, and the point O dash in such a way that the distance between these two pinholes is divided into two equal parts. So S1D will be equal to S2T, and this will be equal to D by 2. Now in order to find the constructive interference or the destructive interference at the randomly chosen point P on this screen y dash, we will be using the formula that delta x is the path difference between the two light waves. This should be equal to n lambda for the constructive interference. Now in the case of constructive interference, we get the bright fringes. Constructive interference produces bright fringes, and the destructive interference produces the dark fringes. And delta x will be equal to 2n minus 1 lambda by 2 in the case of destructive interference. And destructive interference produces dark fringes. So for finding the distance of the nth bright fringe or the nth dark fringe from the center of this screen y dash, we have to find the path difference between these two light waves. So the path difference will be equal to, say, delta x. This will be equal to S2p minus S1p in this experiment. So we have to for now find the value of S2p and S1p, and thereafter we will be able to find the path difference, and then this path difference will be equated to n lambda for getting the bright fringe, and it will be equated to n minus 1 lambda by 2 in order to get the dark fringe. So now S2p is equal to this S2p will be equal to how much? That is d square under root of d square plus x plus d by 2. Now here x is what? Plus d by 2 whole square. Here x is the distance of this point P from the center of the screen. So S1p will be equal to d square plus x minus d upon 2 square. Now from these two equations, I will be getting S2p square minus S1p square. That is after squaring these two equations and then subtracting this S1p square from this S2p square, I will be getting the value as this d square and d square will get cancelled out, x square and d square upon 4 we will also get cancelled out, and simply I will be left with 2xd. Now this S2p square minus S1p can be written as S2p plus S1p multiplied by S2p minus S1p, and this is equal to 2xd. So S2P minus S1P, this will be equal to 2XD divided by S2P plus S1P. Now since here D is very small in comparison to this the distance between the two screens, therefore this S2P can be taken as approximately equal to D, and similarly S1P can also be taken as approximately equal to capital D. So this S2P plus S1P can be written as 2D, and this is equal to XD upon D. So the path difference between the two light waves which are emanating from these two pinholes will be equal to XD, X multiplied by small d divided by capital D. Now for the constructive interference, or for getting the distance of the nth bright fringe from the center of the screen, n lambda should be equal to XD upon D, or simply we can say that the distance of the nth bright fringe from the center of the screen will be equal to n lambda D upon D, and here n is equal to 0 plus minus 1 plus minus 2 and so on. So for the constructive interference, or you can say the distance of the nth bright fringe from the center of the screen will be equal to n lambda D divided by D. Now let us find the distance of the nth dark fringe from the center of the screen. So for getting the dark fringe, the path difference between the two light waves will be equal to 2n minus 1 lambda upon 2, and this will be equal to XD upon D. So from this equation, the value of the distance of the nth dark fringe from the center of the screen will be equal to this lambda D 2n minus 1 divided by 2D. So this is the distance of the nth dark fringe from the center of the screen, that is YY dash. YY dash is the screen in this figure. So the distance of the nth dark fringe from the center of this screen will be equal to lambda D in bracket 2n minus 1 divided by 2D. So thank you very much for joining this session. In the next session, I will be discussing about the fringe width, and I will be also discussing about the displacement of the fringe width. So till then, have a nice day. Bye.